In the beginning, there was darkness, and then bang, giving birth to an endless expanding existence of time, space, and matter. Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. This cosmic world is unlike anything you've ever seen or learned about. Our galactic neighborhood is home to 7 of the most mesmerizing, violent, and otherworldly phenomena in the universe. A stunning planet whose iconic rings contain mountain ranges that rival the Alps. A shimmering moon where massive geysers of water and ice spew from its surface. Scale a mega volcano. Then zigzag through a family of asteroids before diving into the eye of a supersized hurricane. Experience the newest, most mind-blowing discoveries revolving around our sun as we venture in 3D to the 7 wonders of our solar system. If you think science has already uncovered every dangerous, strange, and extraordinary phenomenon under the sun, think again. We are right now in the midst of the greatest era of space discovery. And many of the weird and wondrous things are happening right here in our own cosmic backyard.
Our solar system is a really fantastic place. You know, we've now found other planetary systems, and we've not yet found anything quite like our solar system.
You've joined us on a magical 3D journey through the 7 wonders of our solar system. We first head for the orbit of Saturn. Number 7, Enceladus. It's midnight, November 2nd, 2009. NASA's Cassini spacecraft orbits the planet Saturn. Its cameras capture something bizarre on one of its outer moons, named Enceladus. Most of the solar system's moons are geologically dead, and looking at the glistening icy surface of its south pole, Enceladus seems like a peaceful world. Then suddenly, without warning, gargantuan geysers of water and ice eject from cracks on its surface.
Enceladus is a fantastic moon of Saturn. Though it's relatively small, Enceladus is different from the volcanism that's here on Earth, where hot magma, which is basically molten rock, comes out from underneath Earth's surface. Enceladus has water, basically, liquid water coming out and freezing, and so it's called cryovolcanism.
The Cassini spacecraft flies directly through the energetic plumes that blast hundreds of miles into space at 1,400 miles per hour.
Enceladus has really caught our imagination recently because we see geysers coming out of the South Pole. We haven't seen anything like that on any of the icy moons in the outer solar system. So something is going on in Enceladus, and it's active, and we want to know why.
Scientists have counted at least 30 geyser jets spouting from narrow geological fractures called tiger stripes, located along Enceladus's south polar region. A new 3D infrared map of the area reveals warm surface temperatures. The heat emanating from the tiger stripes may be due to the upwelling of water vapor that propels the jets. One of the few other places to witness this truly fascinating wonder is on Earth. At a freshly groomed ski slope, or on a movie set.
Wow, look at this snowmaking machine. It's like a geyser from Enceladus. All these ice particles and water droplets freeze when they encounter the outside air. And the expanding gases also help cool the droplets and freeze them. In the case of Enceladus, heated liquid water in a cauldron below the surface goes squirting out through some vents in the south polar region. And when that water comes out and encounters the cold surrounding space, it freezes, forming snowflakes and ice particles, much like the ones coming out of this snowmaking machine. So wow, I might as well be on Enceladus right now.
Scientists think there must be two internal heat sources driving this icy volcanism on Enceladus. One source could be radioactive elements that decay and heat up the interior, thereby keeping the water in a liquid state. The second could be tidal heating.
Suppose Enceladus is like this squishy balloon. Now, Enceladus orbits Saturn in a slightly elliptical, eccentric orbit. So sometimes it's closer to Saturn, sometimes it's farther away. When it's close to Saturn, Saturn's gravitational pull creates a greater tidal stretching of Enceladus than when Enceladus is farther away. That leads to a rubbing of the interior materials and a release of energy. This tidal friction, as it's called, helps melt the interior of Enceladus and keep the water in this molten or partly molten state.
One mystery is how much water actually exists beneath the surface. Could the miniature moon be hiding an underground ocean?
We infer that there is a liquid ocean because there needs to be a source of water to power these geysers. The ocean may not extend under the entire globe of Enceladus. It may be just beneath these regions where the geysers are going off, but there has to be a significant reservoir of liquid water beneath the surface of Enceladus.
If liquid water exists beneath the surface, it could be teeming with organic molecules. These, along with relatively warm temperatures, are the essential ingredients for creating life.
It would be incredible if we were to find life, primitive life, underneath the surface of Enceladus. We don't expect complex creatures such as ourselves or rabbits or turtles, but even primitive bacterial or microbial life, independent of life on Earth, would be one of the greatest discoveries ever.
Enceladus actually orbits within another wonder of the solar system. Number 6, the rings of Saturn. The rings, named in alphabetical order as they were discovered, are among the most dazzling sights in the sky.
The Voyager spacecraft first visited Saturn quite a while ago. And now with the new images provided by Cassini, it's like putting on a pair of 3D glasses for the first time to be able to see with great detail what's inside Saturn's rings.
Among the 7 main rings, it's estimated that the gaseous planet has thousands of ringlets comprised of 35 trillion tons of ice and dust, containing roughly 26 million times the amount of water on Earth. Yet their origin has eluded scientists for centuries.
We really don't know their origin. They may consist of material that never had a chance to form into a moon because of gravitational influences of Saturn itself. Or maybe they're a moon that wandered too close to Saturn and got broken up, shattered by the tidal gravitational effects of Saturn. Or possibly even a comet came in too close to Saturn and got tidally disrupted by Saturn's immense gravitational field.
What's even more remarkable is that scientists have counted 62 moons embedded in Saturn's rings. New images indicate that these tiny satellites have taken the rings to new heights. August 11th, 2009. A rare equinox photo of Saturn shows her rings edge on to the sun. The image unveils a shocking fact. The bright bands that once appeared to be solid and flat actually contain ridges spanning from a few feet to mountain ranges taller than the Alps.
When you look at Saturn's rings from a telescope on Earth, they look completely smooth and featureless. But now we see that there are regions where the ring particles are piled up into what you could call mountains, which can be several miles high.
But how are these mile-high mountains formed? NASA's Cassini mission actually captured images of embedded moons sweeping through Saturn's rings, causing them to twist and ripple, creating ever-changing patterns. In Saturn's A ring, the outermost of the large bright rings, the moon Daphnis has carved a vertical peak, which is over 2.5 miles high.
The moons are interacting with Saturn's rings in such a way as to either pull material slightly above the ring or below the ring as the moon goes round, because its orbit doesn't quite match that of the ring itself.
The ring system surrounding Saturn is a spectacular sight. But on a neighboring planet, there's a very different scene, one almost too monstrous to believe. It's number 5 in our countdown of the 7 amazing wonders. A raging storm that's nearly 3 times the size of Earth. As we continue our countdown of the 7 wonders of our solar system, we leave behind number 7, Enceladus, and number 6, the rings of Saturn. We now blast off to number 5, Jupiter's Great Red Spot. This mother of all storms is about 3 times the size of Earth.
We don't know exactly how the red spot formed. It's been there as long as we've been looking, as far back as the 1650s. So it was there before we started really paying attention.
The Great Red Spot is actually an ancient storm that's been spinning wildly for centuries. The supersized vortex towers 5 miles above the planet's cloud tops and dwarfs any storm system on Earth.
The 400-mile-an-hour winds measured in Jupiter's Great Red Spot are faster than some of the most powerful winds measured in tornadoes here on Earth. Yet tornadoes on Earth only last maybe a few tens of minutes, or at most a couple of hours, whereas Jupiter's Great Red Spot's been going strong for at least 400 years, and it's 3 times the size of Earth. Now that's one storm you don't want to get caught in.
Most tropical storms in Earth's southern hemisphere spin clockwise as our planet rotates. But on Jupiter, the Great Red Spot follows an unearthly path.
The Great Red Spot, which is in Jupiter's southern hemisphere, rotates counterclockwise. It's anticyclonic. And that's because it's a high-pressure system, unlike the low-pressure systems here on Earth associated with storms. So when you have a high-pressure system, the airflow is naturally the opposite to that of a low-pressure system.
Regardless of how life started, a fortunate event made it possible for complex creatures to evolve. About 3 billion years ago, ancient underwater bacteria began to use water, carbon dioxide, and the sun's energy to produce carbohydrates in order to survive. This process, called photosynthesis, injected vast amounts of oxygen into seawater and eventually our atmosphere. Regardless of how life started, a fortunate event made it possible for complex creatures to evolve. About 3 billion years ago, ancient underwater bacteria began to use water, carbon dioxide, and the sun's energy to produce carbohydrates in order to survive. This process, called photosynthesis, injected vast amounts of oxygen into seawater and eventually our atmosphere.
How about this?
Here comes